Welcome back to YouTube. We're just looking at the Dynamyte 2400 that's receiving a centroid Acorn upgrade. I posted one video previously which was showing the adapters to convert a modern direct drive stepper in place of the geared small steppers. They're all in place. What they are, they're all the same, but what we have is just an aluminium piece, grub screwed and then driven down via onto the existing hub. I basically pulled the thing down, given it a good cleanup. It's still quite a bit of work to do, but it moves under its own power, and it's just about ready to start making its first chips. The oiler is rehooked up. I just need one single hose remade from there to there, and to run the 110 volt feed out the side of the cabinet. Now I've gutted the bulk of the spindle control, which used to be a potentiometer. Now it's controlled by the Acorn. All the backlash has been adjusted on all of the axes, and with no compensation, it has in the order of 1 to 1.5 thou backlash, pretty much on all the axes. So they've got a plastic nut, anti-backlash nut. So I've done those up to where it was comfortable, and that's what it's ended up at, about 1.25 thou. For an Acme thread machine, I'm calling that good. There's compensation on the controller, which is in place now, and it does repeat reasonably well across the whole thread. For a small machine, it's going to have to do. Just a quick walk around. I'm still deciding what sort of vise I run on it, whether or not I use my grinding vise, which I don't really want to do. I'm a bit of an amateur at this, so I can see quite a bit of damage to my grinding vise, which I don't want to do. So run around, there's still more to do. At the moment, the steppers are controlled from the lab power supply. So to work our way through the electrical box, at the moment, the power supply is supplying the big capacitor, which supplies the 3 steppers online drivers. Now, what I do have for the power supply is a 240 volt, so we're Australia, to 32 volt AC transformer. It's a big one, so it's got more than enough to run the 3 axes, and if I do eventually want to put a 4th axis on this, I don't know if it'll fit, but if I do, it's got enough power to supply that. I've got the bits for it. I've got the bridge rectifier, so it's simple, very simple setup, just a bridge rectifier to the capacitor. The only thing is I want to make a good heatsink, and I don't really know where to sit it just yet, so I'll have to make a heatsink up for the 50 amp bridge rectifier, which I will show to you. Now, these are really cheap from our Australian supplier, RS Components, if you buy bulk of them, so they're always very handy. So push on terminals and bolt down terminals on the capacitor. The capacitor wasn't cheap. The Spindle Controller is the original from the Dynamyte. It's 110 volt input. Now, this is the original 240 volt to 110 volt AC transformer. It's running through the Acorn, so through the Acorn relays. At the moment, I've only got a couple wired up. I've got the Spindle is really the only one that's wired up. So Spindle power supply goes to input relay 8, comes out through the filter then up to the spindle head. Now, the Acorn's mounted up on this side, trying to sort of separate things as much as I can. The homing switches are all set up. The emergency stop is not a good idea to do that last, but I haven't done that yet. Power supply for the Acorn, I've pinched a 5-volt supply to go to the original DC spindle driver, which is basically an on-off switch, and rather than using the potentiometer for that, I've used the signal from the Acorn to go via the KBSI board as basic an interface. So this will only accept 0 to 5 volt signal. Acorn shoots out a 0 to 10 volt signal, but this will isolate any noise coming back and basically turn that thing into pixie dust. So wasn't that cheap, but I suppose it's pretty good insurance at that. That's the warranty. So really the only thing that's left in here is the bridge rectifier, some wire to the capacitor, and basically forms sort of an enclosure that helps it work. Now, what I've done is just a quick program to demonstrate, I suppose. Just a bit of pocket milling, so it's a block face off, then bore a hole. I think it's about a 1.5 inch hole. So calls for a tool change. Now, the actual bearing in the DC motor is not the quietest bearing, so I'm probably going to pull that down. The spindle's nice, but pull the DC motor down and maybe throw some new bearings in it. Now, it's a 10,000 RPM spindle. I've measured run out on the inside of the spindle taper. It runs at around the 2 to 3/10, so it's not great, but it's a fairly anemic machine, and I suppose it is what it is. I'm probably just going to have to get myself a really good set of collets, give myself a really good set of collets and run with that. So it's an ER16 taper, fixed taper inside the spindle, so no, all tool changes require a probe, which I'm going to have to do yet, and set off every tool separately. But yeah, that's basically it. Yet to make chips, but it'll happen soon. It's progress. Enjoy.